Hello, everybody. My name is Alex Gorbanov. I've been working for AT&T as a network architect. And my presentation is about the SDN and NFV in AT&T network. So we had earlier some presentations about the SDN and network function virtualization. And this is real. That's what we have in production network. I was going to explain the network, what challenges we have faced, and why we even decided to go with the SDN network function virtualization, because that's the main question, okay. So why we even decided to go with the network function virtualization. And to explain that, let me briefly describe what we're doing. So we're wireless service provider. And this picture explains some network elements which you have in the wireless network. So whenever you use your iPhone or cell phone, you will be connected to this network. And this network needs to be interconnected with the firewalls, with load balancers, with the proxies, with everything that we have in the IP world. And this network is also traditionally is a physical network. So everything which we have is a physical hardware. We have a lot of hardware from different vendors, from Cisco, from Juniper. Whatever we have in the market, we probably have it in our data center. And our network is also changing. And the main reason for that it's a 5G, for example. Let me explain 5G from networking perspective. What is 5G? 5G, it means that your cell phone can get a 1 gigabit per second. And it's very expensive to build this network. It's very expensive to build the radio coverage which can support at 1 gigabit per second. And we need to also to adapt and to change our core network to be able to support this throughput. And this is a pretty challenging because how can you identify where you should add the more capacity? The problem is that our subscribers are constantly moving. So at the morning, people are commuting to the office. They're moving to, for example, in Seattle. And at the evening, they're moving back from Seattle. So in that case, if we put some capacity to the data center in Seattle, then we don't use it at the evening time. And this is very expensive because we have a lot of hardware and it consumes some electricity, so it will be pretty expensive just to add hardware everywhere. So the best case would was to be somehow like some liquid applications. So when we can move our capacity to city and then we can move it out. So, and for example, then we have a national event like a Super Bowl, and we want to add more capacity to this, And we don't want to put because if we put like a lot of hardware, that again will be very expensive. It takes a lot of time to integrate it. It's very time consuming. So we want to quickly move capacity and then remove this capacity. And then Internet of Things. It's also a very interesting case. It's like a lot of cheap devices, and they have usually very small TCP sessions. They can send like a few packets, and then they can wait, and then can send up again a few packets. And the problem is that also they're not very secure, so sometimes they need to do firmware upgrades or to download or to upload something. And we cannot predict when it happens. So we have like thousands, maybe in the future we will get millions of these devices. And even in theory, we cannot make it manual. We cannot manually add some capacity. When, for example, there is a security upgrade and we need to immediately upgrade a lot of IT devices. So this is not possible to do it without some kind when network can identify what traffic is going to the IT device and can add capacity by demand. So it can really understand what this IT device is trying to do and try to then to add it more capacity. And so the main problem which we have is like how to easily we can add capacity, how can we identify traffic and scale if it's needed, and descale back, because it's actually, again, very expensive to run a lot of applications. And then also what we need to have in our network, it's some kind of global policy-based routing, I would say. So we don't make routing based on like just IP destination. Yeah, we need to know who is the subscriber. We need to know what the subscriber is doing. We need to know what's the date of time, where the subscriber is located, if it's a IoT device or it's a real physical person. And then based on that information, we can set up some policy-based routing that this flow should go to the firewall and this flow should go to the load balancer. And this policy can be very complex and can be very dynamic. So it's our best network which we want to implement will be like very dynamically scalable, so it can identify traffic, it can quickly scale, it can quickly add more capacity, it can geographically distribute capacity, and it can set up very complex rules how we want to process this traffic. With physical infrastructure, it's almost impossible to do it. So So what ways we have to solve this problem? One possible way is like to copy some successful strategy from different industries. So we decided to try virtualization. Yeah, not like at that time it wasn't SDN or network function virtualization. It was just a virtualization. Yeah. So let's take the application which we have any firewall, load balancer, whatever, and try to take an image from this physical hardware, and then we can deploy it. Yeah, we can deploy it on any hardware. So there's a huge benefit that capacity is going to be that capacity planning is a bit easier. Yeah, because if you have a lot of different hardware vendors and you need to put them to the data center, it's pretty difficult to make a capacity planning properly because you need you have multiple vendors and every vendor has different rules. In that case, you have a commodity service and they can be like pretty easily, you can just create a virtualized application, yeah, and then it's not so difficult to make a capacity planning. And you can achieve the main goal, you can actually easily add capacity, yeah. So if you want, if we have a deep packet inspection which identifies that there is firmware upgrade for IT devices, so we can add capacity on the demand. Yeah, so if we need to have like 20 firewalls, we can add them in the same hour. Yeah, so we don't need to wait a long time for this. And this is one part how we can fix it. Yeah, with the virtualization. And if we're talking about virtualization, we have like two paths. Yeah, we can go with the VMware, which like a commercial software, and it's very long time on the market, and we can go with probably the OpenStack, yeah, which is like open source, and it's also pretty good because IT devices, they're cheap, yeah, so to get any revenue from IT, the network itself should be not so expensive, yeah, so if you go with OpenStack, at least you don't pay for licenses. And but it's only the first way how we can fix this problem. Yeah? The second way is a bit different, and we actually attempted all of them. The second way, let's combine all the network functionality which we want into one box. Let's put like a firewall, load balancer, router, everything that's proxy to the one single box. And we will remove all unnecessary features which we don't use. It will do only what we want, and since it's like in the one box, it's a bit easier again to make a capacity planning. It's a bit easier to scale. We can just put like a few boxes, and we don't need to pay like more money than if we put like a lot of hardware. Yeah. So why we wanted to try this way because you can get all the benefits from hardware. Yeah. So you can do very fast processing, yeah, packet processing. And we have it in whatever I'm explaining, we have everything in production. Yeah. So, and then we decided that's two ways. Yeah. But then there is need for whenever we're talking about the virtualization, we need to also have a solution which will create a network for us, because that's the problem. If you want to dynamically add more capacity, you need to have something which would create a network for you, because the network is not pre-created. There are no VLANs, there are no trunks, there is nothing. So something should create for you. And because we have a requirement for the policy routing, yeah, so we don't need to use any routing protocols because, like OSPF, yeah, because it's not suitable for us. So we need to have some centralized solution which will make a policy-based decision for us. So, and this SDN controller would identify the whole path for the packet based on some information which it has. Yeah, so it can take a lot of information and then make a decision that this packet should go to this to this path. And so that's probably what the main requirement, a very good policy chaining. Yeah. Of course, we have because we're a service provider, we need to provide a quality of service. We need to meet a performance requirement. So, and there is one more important. So, if we're talking about commercial software like a VMware, the process of getting some new functionality is pretty difficult. So we need to make a use case. It goes to the vendor. Vendor agrees or disagrees. Then it's like it releases the version which we can use for us. The problem is that sometimes it's so dynamical, and we cannot make a very good story because after a few months we can discover that we want completely opposite. So, and with the open source, we found that it's a bit easier for us. We can be a lot more flexible. Yeah. So if we decide that we want to go in different direction, with open source it's a lot easier to change. So let me compare all the different approaches. Yeah. So VMware, we have a in production VMware. It's running very well. We like it. So again, getting new features very difficult, and performance is very good, but scaling is also a problem. Yeah, it was very difficult for us to make it scalable, and so we decided that it was that we achieve our goal. We know that at least for us, our experience with virtualization based on VMware was main goal was to answer if we can go virtualization or not. So if it fails, then basically we're not going to go with this path. But VMware was successful, so then we decided that because of the cost, yeah, because we need to pay a lot of, we need to buy licenses, because it's very difficult to get new features, we decided that if we go with the virtualization, that should be OpenStack. And then we attempted a different, so we hired one vendor who made for us a box. It was a load balancing, everything was in the box. Again, it works very well. We have it in production network. It's like a one single box which is doing everything which you want. Yeah? And again, the problem was that we were only a single customer for this vendor. And everything, whatever vendor was doing, it was only for us. So there was no support of community. Yeah? So if we need to have a new features or whatever, then it only will be, if there is a bug, then only our network will discover this bug. And that was also the experience that it's better to not to go with the proprietary solutions. Yeah? Because yes, from short-term perspective, they are excellent. Yeah? You can do something very, very fast, but from long-term perspective, basically nobody is going to support you in terms of that all the bugs will be all yours. Yeah? And then we did evaluation of all OpenFlow controllers and everything that was on the market. Yeah, because initially we thought that we should deploy something with the OpenFlow. The problem which we discovered is we didn't know, we have a network already, yeah? We have an MPLS network, we have already a lot of hardware, we have a lot of switches, routers, and the problem which we have, like we already investment in our network, and we didn't want to lose these investments. So what would be the reason for us to buy some new switches which support OpenFlow, and then what we should do with our existing infrastructure? So we decided that we need to find something which can we utilize with our existing hardware, and that's what we decided. Then we go with the OpenContrail. So I would explain more all these features. Yeah. So basically, that's comparison, yeah, different approaches. So the main reason why we selected OpenContrail that we can do dynamic scalability, we can do very fast deployment, and we can integrate OpenContrail to existing network. Yeah, so we don't need to spend money on some new hardware. Yeah, so we can utilize whatever we have in our network. So let me explain what the OpenContrail is a overlay solution. So we need to deploy underlay, and that's underlay we already had. So we had already all the routers, like on the bottom we see management routers, then we have a compute host, yeah, and then we have like a leaf and spine infrastructure. I just draw like very simple example, yeah, with the eBGP, and then you can easily add some more switches, yeah, more compute hosts, yeah. So this infrastructure we already had, yeah. So this is a huge benefit. We don't need to buy anything else, yeah. We just can introduce at least one small element, yeah. And that's the OpenContrail, which goes with the OpenStack, yeah. So you see that OpenContrail has an OpenStack, and it has an API, yeah, so it can communicate with OpenStack. It has it's using the traditional technology, which we'll know how it works. It's MPBGP, yeah? So you don't need to train your operational team from this perspective because they already know what's MPBGP. Yeah? So again, you can save some money on trainings, yeah? So it has a control plane. Again, it has a XMPP protocol to the compute host. Yeah, that's how the control is propagating the routing information, yeah? And then virtual machine is connected, so the virtual machine has a virtual NIC to the vRouter, and compute host itself has a GRE tunnel with the MPLS label to the external router. Yeah? So that's how we can get an external connection. So you see, this is again, it's all traditional technologies. Yeah. So you can get, if you have a Juniper mix, it will be supported by default. Yeah. So you don't again need to buy anything. It's very scalable. Yeah. Every compute host has a direct access to the external router. And they can communicate between each other. And it's again, everybody knows how it works, so you don't need to train people for that. And from virtual machine perspective, it's not a way even that there is a control, yeah, just using vRoute as a default gateway. So, and the main benefit which we saw, because whenever we were researching the OpenFlow with the OpenV switch, for example, yeah, we didn't like the idea of the floating IP addresses, yeah, because we try to avoid any concept which like with the NAT and with the floating IP addresses, and that's what we like. This whenever we create a network, you can utilize the BGP route targets, yeah. So you create a route target, you create a network with the route targets, and this route targets. When the router has a route instance, yeah, which is configured to import this route targets. So basically, whenever you have a network, the control plane will be a route targets, and the user plane will be GRE tunnel with the MPLS label. Yeah, so that's how it looks in the Wireshark. And you see, everybody who knows this technology will be able to understand and troubleshoot what is happening. So MPLS label is used like to distinguish, to differentiate VMs, to differentiate networks. Yeah, so every network has its own MPLS label. And that's how the short route table looks, yeah. So you see it shows that this network is reachable through this GRE tunnel and then push label 17, yeah. So again, it's a bit easier for operational team because they can understand all this output, yeah. And that's a very simple example which we have, like, it's probably the basic example, yeah, that we want to enforce Contrail to do a policy routing. So, for example, the traffic from protected net should go to firewall, and they should go to direct net directly, yeah. This is a very simple. Of course, it's not very dynamic yet, but at least it's the first step to network which is completely and fully based on policy. Yeah, yeah, that's how it looks in the GUI. Yeah, you see, this is extremely easy to configure. You can configure from which network you want to go. Please use, so this traffic will go to this virtual machine. Then I'm going to explain some features which we really liked, and mostly from most of the SDN controllers, from most SDN solutions, we're expecting to get these features, yeah? So public address, that's of course clear because we can use again network with route targets. And then you get like access, you don't need to have any private IP addressing. Yeah, L2 networks, they're heavily used in our network. So whenever we have a SDN, yeah, we need to support L2 networks. You see, that's how it looks. It's very easy actually to configure. You can configure it from GUI, and it's you don't need to have like a lot of trainings for that. Yeah, it's just because it's like standard network concept. Yeah, and then you have some nice features like a reserve path forwarding. Usually, it's enabled by default. Yeah, so and everybody can understand this. Trunking. So because we have a lot of virtual machines like for service providers. Yeah, and service providers usually use VLANs to differentiate customers. And we still have applications which are required to support trunking, and Contrail supports this very well. So Contrail would assign a VLAN, so it will assign a sub-interface. In that case, the router is doing this, but then when VM is sending the sub-interface packet, it will remove this VLAN tag and assign the PLS label. So it's again the same concept that it knows that if the router is receiving this MPLS label, it needs to assign this sub-interface VLAN tag, and it will go to VM. So if you have any virtual machine, or if you have, like, usually it's a voice over IP application, which is required, then Contrail will support it. And whatever I'm explaining, we have in production network. So it works really under some load, yeah. This is a very important requirement for us, cross marking and remarking, and then priority queuing, yeah, because we want to avoid a situation when we have on the same compute host, when we have a VM which is intensively sending some traffic, and we have a VM which is a voice over IP application, yeah, and then we need to have a strict priority queuing, yeah, and this is what we must provide, yeah. That's Contrail support, so it can organize the priority queuing for the voice over IP traffic. Jumbo frame support, yeah, of course it's like must have HTTP protocol, yeah. This is a requirement for mostly for telecom world, yeah, and Contrail supports it very well, yeah, because we heavily use it. High availability, so this feature is like very close to something like HSRP or VRRP, and Contrail also supports it, yeah, so you can assign like a loopback to different virtual machines, yeah, and then Contrail will do like a load balancing between in this case from this loopback. This is a bit different, so it's about that in our case in telecom world, we have an application which are actively participating in the routing, yeah. In that case, this application needs to advertise some routes, yeah. This is a static route advertisement, and you can look like that's how easy it looks like, yeah. So everybody can understand what is the static route, yeah. And Contrail also supports BGP. So if you have a virtual machine, probably some router, yeah, you can establish a BGP connection to the router, and then it will be propagated through the control SDN through the MPBGP to the external router, yeah. So we have a lot of VMs which are actively participating in the routing, yeah. It might be different from web applications, yeah, which are not really advertising some prefixes, but we have a lot of these cases. Port check is a very nice feature, yeah, because if VM is not functioning, yeah, then the port check can remove this VM, and this is very useful, and we heavily use it, yeah, because we need to identify which virtual machine is not running, and Contrail supports a very nice feature. CMP hashing. We had a meeting, we had a presentation yesterday, yeah. Contrail supports it very well, so you can select a lot of fields, yeah, which you want to use for CMP hashing, and this is extremely useful feature. We also use it very often. Yeah. So let me explain about the automation, because we have Contrail itself, but Contrail is not only about features, not only about the capacity on demand, it's also about the automation. Because now, whenever you create your network design, you basically create some templates. Yeah? In our case, we're using the HIT templates to deploy your networks. Yeah. So, and this is very look how we're deploying our networks. Yeah. You're executing just one command, hit stack create, and then it can deploy the whole mobility network for you. So this example, yeah, for example, how you can describe L3 network, yeah, and it's not so difficult to read, yeah. Usually our operational team, they really understand what's happening because it's using the known terminology from BGP, yeah. So we usually don't have a problems with understanding this. That's how you can explain whole your network, and that's how our process of design of our network has changed, yeah. So before that, we did a lot of document with describing which changes we need to make. And now we have like only scripts and templates. Yeah. So most of the time we spend like on developing and testing these heat templates. That's the process. Yeah. And deployment itself is like a 1 minute task. So if we're discussing like a job security, you can look here, yeah, who's involved mostly. So you see most of the time, you're basically trying to understand how you should develop your network, yeah. Then you can test, you can perform some testing, and usually if you perform some testing, usually it will be the person who did the design, yeah, because only that person understands it very well. And then deployment itself and operational support, it almost does not exist, yeah, because deployment is just one command. So you can understand how it significantly would affect, yeah, and how significantly affected us, yeah, the new process. So the lessons learned, yeah, the lessons what we learned. The first lesson that cloud availability is like around 3 nines, yeah. And the reason for that we have like multiple levels of file array. So you have a hypervisor, you have underlay, you have overlay, you have different OpenStack components, yeah. So there are a lot of places where it can fail. And for us, it means that we need to utilize all technologies, all the methods, all the ways to make a network more reliable, yeah, or make application more reliable. So, for example, in the Linux world, there's applications called supervised, yeah, which can monitor the process and then can restart it, yeah, if it's for some reason doesn't work, yeah. It's very good, and we are trying to enforce our application owners, yeah, to have more health checks, to have more features how they can verify that the application is running, yeah. IPv6 is actually very easy to miss if you're focusing only on IPv4, yeah. So that's also good because you think that everything works, but then you can find out that you have missed something from IPv6, and that was a lesson for us. And the process what I described is more close now to software development, yeah. So you develop something, it's usually some scripting, yeah. You deploy it, you test it. So it's better to know some best practices of software development because in that case, it's the network development itself is very close to some software development. Cinder storage, yeah, that's OpenStack terminology, but basically we have found out that storage which we use for our databases, yeah, it's extremely sensitive for any data, for any packet loss, yeah. And that was a good lesson, and that might be very important, yeah, for all other cloud providers, yeah, because if you need to develop your storage for some Cinder, for databases, yeah, you need to be very careful how what are you going to do when it fails, yeah, because most of the time this database you need to go manually and do something, yeah, it cannot recover by itself. And extensive testing is required because now we have like a lot of open source components, yeah, and we are integrating them. And for us, it means that there are some bugs which are undiscovered, yeah. So we now in the AT&T we're spending a lot of time and a lot of our efforts to make end-to-end testing. And performance testing is the same, yeah, because whatever we also find out that whatever vendor information was provided to us, it could be based on different traffic patterns, yeah, and we could have a completely different picture in our network, yeah. So if we go with open source, if we go like with this open source SDN, yeah, basically it means that your company would spend a lot of efforts just to testing it from end-to-end perspective. So that's basically all my presentation. Thank you.
Thank you for that presentation, Matt Petak from Yahoo. You said your cloud availability was 99.9%, so you're down for roughly an hour a month. Is that what you were saying?
It's a production environment, but we are very closely monitoring it. Yeah. So if it's like if it's a down, then like quickly can migrate to physical environment. We still have, yeah. So it's like a first stage of migration to the cloud. But this availability means that you should be ready, yeah, to react for this. At least on the first stage, yeah, because whenever you have more experience with the end-to-end testing, yeah, whenever you know when it can fail, then it will be like the situation will be better, yeah. But now, whenever you just have first deployment, cloud availability wouldn't be so good, yeah.
Okay, so that'd be something you'd expect to be improving over time.
Yeah, it will be definitely improved, yeah.
Good,
Yeah.
because the number didn't sound terribly good.
Yeah, of course it will be improved, yeah.
Thank you.
Mhm.